I'm going to show the previous example in a slightly different way. So just to remember, we had a 70% probability that Sarah will see David and a 40% probability that she has gum in her pocket. So what we know is there's a 70% probability that Sarah will see David. So what we have is there's a 70% probability that she sees David and a 30% probability that she does not see David. And there's a 40% probability that she has gum in her pocket. Now what that means is, oops, I'm going to use the same color actually. There's a 40% she has gum in her pocket, and there's a 60% probability that she does not have gum in her pocket. And if she doesn't see David, it's the same thing because these are independent events. So there's a 40% probability that she has gum in her pocket, and a 60% probability that she does not have gum in her pocket. And now the probability of seeing David and having gum in her pocket is going to be this times this, which is going to be 0.7 times 0.4, which is 28%, which is the one we already did. And this one would be 0.7 times 0.6, which would be 42%. 42% is the probability of seeing David and not having gum. No David, not seeing David and having gum in the pocket would be 12%, and not seeing David and not having any gum would be 18%. And that's kind of a weighted probability tree. It's a way of showing the values. We're going to come back to that in a little bit. Example 3. Pause it, write it down, but don't try to solve it, I think. This one will be tough to solve. So if Stan sees Wendy, there's a 70% probability that he will vomit. If he does not see Wendy, the probability of vomiting is 20%, substantially lower. There's a 35% probability that Stan will see Wendy. And so the question is, what is the probability that Stan sees Wendy and vomits? What's the probability that Stan vomits in general? Okay. So what we're going to do, we're going to make another one of those weighted tree diagrams for this thing. So we know that the probability of seeing Wendy is 35%. There's a 35% probability that Stan will see Wendy. So a 35% chance that he sees Wendy, which means that there is a 65% chance that he does not see Wendy. And the probability that he vomits depends on whether he sees Wendy. So these two events are not independent, they depend on each other. So what's going to happen here is the probability that if he sees Wendy, there's a 70% chance that he will vomit. So if he sees Wendy, there's a 70% chance that he will vomit. If he does not see Wendy, if he sees Wendy, of course, there's a 30% chance that he won't vomit. If he does not see Wendy, the probability of vomiting is only 20%, which means there's an 80% chance that he will not vomit. And then what we could do is we could find the probability of each of these things. The probability of seeing Wendy and vomiting is going to be 0.35 times 0.7, which is going to be 24.5%. Seeing Wendy and not vomiting is going to be 10.5%. These two numbers add up to there. That was true for the other one as well, if you recall. All right, the 42 and the 28 add up to the 70, the 12 and the 18 added up to 30. Not actually a fluke, in case you were looking at that. 65 times 20, that's going to be 13%, which means this will probably be 52. 0.65 times 0.8 is indeed 52%. So, the question we were asking is, what is the probability that Stan sees Wendy and vomits? So the probability of seeing Wendy and vomiting is that? It's going to be 24.5%. What's the probability that Stan vomits? Now, there's actually two ways for Stan to vomit. He could either vomit by seeing Wendy and then vomiting, or he could not see Wendy and still vomit. So these are the two ways for him to do it. And what we're going to do is we're just going to add those together. So that's going to be 24.5 plus 13. Which is going to be 37.5%. Now, and that is it.